Welcome to the demo of Kronos2, which is a data mining application which is available via web app, so it can be viewed on any device. Today we are powering Kronos on the iPad, and just to show its features, we also have an iPhone with the same. So, what is Kronos? Kronos is a data mining app which looks at data from the University of Maryland's Global Terrorism Database, which is 90,000 terrorism events, approximately 90,000, that cover from 1970 to 2010. Our application uses Cincha Touch 2.0 for the web application user interface, and let's dive right in. So, this is our homepage. As you can tell, we have our logo here, and we have a basic search box. What we're going to do here is we're going to search Hamas. We're going to do a few things with this. We're going to first look at the results of Hamas comes out from the GTD, Global Terrorism Database. As you can tell, we have 264 events that come up. Our first page here is just displaying 1 to 10. Cincha harnesses what we've all grown accustomed to, the touch interface for navigating through things. We want to go to the next page. To go to page 2, we swipe, and there's the second page, third page, and so forth. Now, let's go back to that very first page. If we want to see an event, we can just simply click on it, and a shadow box pops up. This shadow box has a map of the event, or where it's taking place. We can navigate around. It's not static. We can also see some more events about that event, about the terrorism attack. The date, a description, a location, attack type, a group that's responsible, etc. If we also want to, we can also go see a map of these 10 events here. Since our application Kronos uses Google Maps API for the map rendering, and here is the 10 events. Some events from the same location, you can tap on them just like we did, and you can tap on one of those events. See the shadow box that we just saw. Now also, so far we've just seen the information retrieval aspects of Kronos. Now we're also going to look at the data mining aspects. So what we have here is we have a naive Bayes classifier, which we're going to run against the data, the 264 items that we returned from our Hamas query. And we're going to train a model and test a model and see its accuracy. So let's click on Generate Model. And what comes up is a listing of events, in this case 218 events, which is 90% of the data because we used a bootstrapping 90% algorithm for sampling and testing, and the accuracy of our model is 66%. And what this does is this means that for the 218 events here, the naive Bayes classifier model that was trained was able to correctly predict 68% of the groups responsible for the events in the testing data set, which was part of the 264 events that we returned. We incorrectly had classified 73 of those. Now we can click on one of these events and maybe see a little bit of information. The same shadow box pops up, but now we have a confidence level, the actual group, the predicted group. In this case, we were right, the date and the location for that event. We can click on the Fields button. What the Fields button says is this is basically the query that we originally ran, just Hamas across the entire data set. These dates is the earliest date and the latest date for information. We can sort by confidence level, ascending and descending. Obviously the descending levels, the lower confidence levels, are incorrect predictions. We can sort by date, ascending and descending. We can go over and do some filters. We can just look at the incorrect classifications, or just the correct classifications. There we go. So now let's see if we can improve the accuracy. Remember, the accuracy of this model was 66%. So let's go back to that home page. Let's go to Advanced Search. What we're going to do here is we're going to type in our Hamas query again, but this time we're only going to look at the last 5 years of data in the data set, which will be January 1st, 2005 to December 31st, 2010. Let's go ahead and pull all the pages, all the items on one page. I'll show you why we're going to do that here in a sec. We hit search, and we go back to the list of data, In this case, we have 119 items, and you see there's only one page, so we can't swipe back and forth, but we can scroll down just like we did. Let's go to the map view real quickly. And now we're going to see all of the map, all those items on one map. As you see, most of them do focus around one geographic area. We have some other events kind of scattered, one in France over here, some in Southeast Asia. But let's zoom in on these events that are happening in the Israel type area. And as you can see, we have a little heat map for where the events are happening most. Now, obviously, not all the events are rendered here because some of them happen in the same place. But if we click on some of those locations, we see where they spider out like that. Now let's go back to that analysis tab. So let's get the best naive Bayes classifier model we can get. We can do that by generating best model. This takes a brute force approach. So originally that first classifier that we had, that rated in the 60%, I think, what it had done is it had only looked at fields, target type, weapon type used, city and province and city, to create a model for prediction. What the brute force model is, which we just pressed, it takes a little while to load, is it's going to take every possible iteration of all of these values and create the highest accuracy percentage model for predicting the correct terrorist group responsible for a certain event. It uses the exact same bootstrapping method of 90% for testing and 90% for training, and we'll see what happens. So while that's going through, let's see if let's go ahead and run the exact same model we did earlier. Let's see what the results are. This is just, we've trained 5 years and our accuracy went up to 80%. So now we know that actually if we just look at those past 5 years alone, our model accuracy goes up. And we can filter them if we want to see those incorrect guys. Here's where they are. Let's go back to the analysis tab. We also have a few other classifiers. We have the default lazy learner if we want to look it up. It's at 77%, pretty accurate. We also have a k nearest neighbors classifier, which is at 85%. What we can also do is let's go to a manual generation. Our brute force just ended. 97% accuracy if we select city, multiple, attack type, target type, corporation, nationality, and Latin long is our fields here to create our model. So that is what we've done there. Now we could also change the sampling site from ratio bootstrapping to bootstrapping by date, where our training and testing falls on a certain date range. So that is the generation model, the classification model in a nutshell. Let's do another query. Let's go away from Hamas. Let's look at India. We're only going to look at India for the last 3 years in the data set. 2008, 2010, just going to view the first 10 items on a page this time. We have about 2,000, a little bit less than 2,000, about 1727 unique events. Let's go to charts. Charts is a data visualization tool unique to Cincha, and what charts does is it displays the data we're looking at, and we can compare it against other sets of data and various charts that we've all grown familiar with, and a couple of ones that actually are a little more intuitive and native to the Cincha Touch platform. So what I'm doing here is I'm selecting a few different data sets. The terrorism events that we just searched for, just for those 3 years in India, and a little bit of economic data that's related to India. In this case, it is the stock market prices for India across that same 3-year time frame. We'll click on View Chart, see what happens. It's going to pull up a line chart, and this line chart in this case covers this time frame. There's our years that we're looking at right here in our data, and I can zoom in if I want to look at something in particular. These little red dots here are all the terrorism events count by day. I can filter off some of other economic data. I can zoom back out. So it's kind of more of a user-driven analysis. Let's pull up another one of these charts. Let's look at the area chart. This is only going to look at the terrorism events, no economic data. And here is 2008, 9, 10, all stacked across accounts per month. I can filter to take some data off. I can zoom in. I can scroll over. Again, just another way to visualize the data we're searching for. Let's try a radar chart. This is going to be a little bit more of a temporal type analysis. It's by month as well. Now here we have 2010, 2009, 2008, and we can see the number of attacks per month. Looks like July has a peak here. Of interest, 2010, see this area here. A little bit more attacks in 2010 in the November and December areas of the year. And we also have a simple pie chart, which is going to display 1 year's worth of data in a pie fashion. If we want to take off maybe the first 3 years and just look at the last 3 quarters of the year. If we want to pull out maybe a piece of data, look really focus on it, we can do that. And that is charts. And that concludes our demo today of Kronos. Hope you enjoyed this, and hopefully you'll get a chance to take a look at it some more. Thank you very much.